Imagine standing in the Atacama Desert, Chile on July the 1st, 2025. Above you, the Milky Way stretches like a river of light, and somewhere in that infinite darkness, something is coming. It has been traveling since before Earth had oceans, since before the sun was born. Tonight it finally arrived, close enough for us to see. But the question isn't what it is. The question is why now? And more terrifying is the worst case scenario already happening. They tell us it's a comet. They tell us it's safe. But sometimes the most frightening thing isn't what we see clearly. It's what disguises itself so perfectly that we believe it's natural. Tonight we tell the story of 3I Atlas, the third interstellar object in human history. Where are you listening from right now? If this calm finds you, you're welcome to stay. Maybe leave a subscribe, a quiet comment, or follow along, like knocking gently on someone's door in the deep of night. Now, let's begin. On the night of July the 1st, 2025, the Atlas telescope in Chile was doing what it does every night, scanning the sky, cataloging the faint wanderers of our solar system, asteroids, comets, space debris, the routine work of cosmic surveillance. Then the detector caught something. At first, there was nothing remarkable about it. A faint object magnitude 14, barely distinguishable from the background stars. It moved slowly against the sky, sliding across the sensor with just enough deviation to warrant attention. The observatory's automated software flagged it for follow-up, part of the endless stream of objects logged every week, one among thousands. Unremarkable. Expected. Another dot awaiting confirmation. But when astronomers began to calculate its orbit, the numbers stopped making sense. Asteroids trace neat ellipses around the sun. Comets stretch those ellipses into longer, more dramatic arcs. But all of them, every single one that belongs to our solar system, share one fundamental characteristic. They return. Gravity bends their paths back toward the sun. They are bound, shackled by the invisible hand of our star's pull. This object refused to return. With each new measurement, the trajectory diverged further from the familiar. The curve refused to close. It opened outward, stretching into a shape that defied the rules of solar captivity, until it became undeniable. The curve was not an ellipse at all. It was a hyperbola, the mathematical fingerprint of something unbound, something that answers to no sun. This object was not orbiting. It was not circling. It was simply passing through. Within hours, the realization spread through the global network of observatories. Emails fired across continents. Phones rang in the middle of the night. Calculations were scribbled hastily on paper, double-checked, triple-checked. Each independent confirmation deepened the sense of astonishment spreading through the astronomical community. Observatories in Hawaii swung their telescopes toward it. Spain followed. Chile's neighboring instruments joined in. Every measurement added another dot to the growing map of its path, and every dot told the same story. Gravity could not hold it. The orbit would not close. The numbers described something that had only been seen twice before in all of human history. For the third time, we were witnessing the arrival of an interstellar visitor. The designation came quickly, following the protocol established with its predecessors. 3I Atlas, the third interstellar object cataloged by science. The name honored the telescope that first caught its faint light, connecting it to the lineage of of cosmic travelers before it: Oumuamua in 2017, Borisov in 2019, and now this, the third messenger from beyond. News rippled outward through scientific channels, then into the wider world. Journalists reached for comparisons. The public, for a moment, paused and looked up, wondering what this meant. Another visitor, another fragment of a distant star system, passing through our neighborhood before vanishing back into the void. But almost immediately, there was something different about this one. Its speed stood out. Its brightness caught attention. Early, spectroscopic readings hinted at chemistry unlike anything cataloged before. From the very moment it entered our awareness, Atlas carried with it a weight of mystery heavier than the mass of its icy nucleus. This was not just another comet drifting through. This was not just another wanderer following the galaxy's currents. This was something stranger. Atlas was not just passing through our solar system. It was passing through our understanding, and the questions it raised began forming almost immediately, whispered between astronomers who knew what the numbers meant, but could not yet say what they implied. If this is the third time we have seen one of these visitors, how many have passed through when no one was watching? But observation is only the first step. What matters is confirmation. And as telescopes around the world turned toward this faint intruder, the careful work of verification began. Over the next 2 nights in early July, observatories across the globe turned their instruments toward the faint object first glimpsed by Atlas. Each telescope added new points to the growing map of its trajectory. Each observation refined the numbers. Each calculation narrowed the uncertainty. And with every measurement, the truth became sharper, clearer, undeniable. The orbit refused to close. Gravity could not capture it. What had appeared at first as merely unusual was now revealed as genuinely extraordinary. In data centers and control rooms, astronomers watched their orbital models update in real time. The eccentricity value, that single number determining whether an object is gravitationally bound or free, climbed steadily with each refinement. 1.01, then 1.1, then higher still. Anything above 1 means escape velocity, a path that never curves back, a trajectory that ends only in the infinite. By the morning of July 3rd, the verdict was unanimous. Across every observatory that had gathered data, this was hyperbolic. This was interstellar. This was confirmed. For the third time in human history, the cosmos had delivered a traveler from beyond our solar system. Oumuamua had been first. Slender and enigmatic, it startled the world in 2017 with its strange shape and inexplicable acceleration before vanishing with more questions than answers. Its mysteries had never been fully resolved, leaving behind trails of speculation that still sparked debate. 2 years later came Borisov, a comet in every recognizable sense, bright active shedding gas and dust as expected, reassuringly normal in its behavior, though still undeniably foreign, still a visitor from another star's family. And now, Atlas, the third, joining this short, strange catalog of objects that belonged elsewhere but found their way here. One detection is luck, a cosmic accident caught by chance. 2 detections is coincidence, surprising but explainable by probability. 3 detections is what a pattern, perhaps, or the first hint of one. The slow, uncomfortable realization that our solar system is not isolated but embedded in a river of debris flowing between the stars. that the void between suns is not empty, but filled with wanderers, countless fragments ejected from planetary systems across the galaxy, drifting through the darkness for eons. If 3 had been found by chance in less than a decade, how many more had passed through unseen? How many had crossed our skies when no telescopes were watching, when humanity was still learning to look up, when our instruments were too crude to notice? The galaxy, it seemed, was far more crowded with these travelers than anyone had imagined. For scientists, this realization brought both excitement and a creeping unease. Each detection added weight to the question: if interstellar objects are this common, if they pass through regularly enough that we can stumble upon 3 in just a few years of watching, then the statistical implications become staggering. There must be millions of them out there, perhaps billions, an invisible diaspora of orphaned worlds scattered and wandering. And if the galaxy is filled with such debris, then what else might be drifting in that darkness between stars? But there was something else about Atlas, something they set it apart from its predecessors, apparent even in these earliest measurements. Not just its presence, though, that alone was remarkable. Not just its origin, though that raised profound questions. It was something in the numbers themselves, in the velocity readings, in the preliminary chemical signatures, in the way it seemed to arrive not just unexpectedly, but impossibly. Atlas was not simply strange. It was strange in a way that felt deliberate, as if chosen, as if timed. And this was only the beginning. The world had confirmed what Atlas was, but confirmation is not understanding. And as the first wave of public announcements began, a careful narrative took shape, one designed to inform, to reassure, and above all, to calm. The first wave of reports came quickly, as they always do when a new object enters the astronomical record. Atlas was classified, described, and placed neatly into the familiar box labeled Comet. The images revealed exactly what one would expect: a faint halo of gas and dust, the telltale coma that blooms when sunlight strikes frozen volatiles. Its orbit, though extraordinary in origin, was still predictable, mathematical, knowable. The distance was calculated with precision: 270 million kilometers at closest approach, safely beyond any threat to Earth, far enough that even the most catastrophic scenario, complete disintegration, sudden trajectory change, would pose no danger to our world. The official language from space agencies around the globe was calm, measured, and deliberately reassuring. This was not a crisis. This was an opportunity, a chance to study something rare, something that had traveled unimaginable distances to pass briefly through our cosmic neighborhood before continuing on its eternal journey. NASA's initial statement struck the tone that would echo through every press release, every briefing, every public communication that followed. No danger to Earth, the announcement read. No threat to our planet. The trajectory had been calculated with exacting precision. The closest approach would occur at a comfortable distance. There was the statement, emphasized nothing to fear. The reassurance extended beyond mere numbers. NASA invoked history, reminding the public of precedent. Oumuamua had come and gone without incident in 2017. Borisov had followed in 2019, behaving exactly as a comet should. Both had passed through, harmlessly observed and catalogued, before vanishing back into the dark. Atlas, they assured us, would be no different. The mathematics was reliable. The models were solid. Celestial mechanics, whatever mysteries the universe might hold, still obeyed the fundamental laws of physics. Gravity worked the same way everywhere. Trajectories could be predicted. The cosmos, chaotic though it might appear, still bent to Newton's equations. And those equations, refined over centuries and tested across countless observations, predicted one thing with absolute certainty: safety. For most people, the message landed exactly as intended. This was digestible, understandable. A comet from another star? Yes, unusual certainly, but still fundamentally a comet. Ice and rock following the same physical laws that governed everything else in the universe. Nothing to lose sleep over. The headlines reflected this measured response, leaning into wonder rather than worry. Third interstellar visitor confirmed. Cosmic messenger from afar. Harmless visitor from the stars. The stories invited fascination without demanding anxiety. They presented Atlas as a curiosity, a scientific opportunity, a reminder of how vast and strange the universe could be, but not as a threat, not as something requiring alarm. The public, for the most part, accepted this framing. Why wouldn't they? The experts were confident. The math was clear, and humanity had been through this twice before, with no consequences beyond expanded understanding. But beneath the surface of these reassuring statements, beneath the carefully chosen words and the confident projections, there were details that didn't quite fit the comfortable narrative being presented to the world. The velocity stood out immediately to anyone looking closely at the numbers. 61 kilometers per second, more than 130,000 miles per hour, nearly double the speed of Oumuamua, leaving Borisov trailing far behind like a slow caravan in comparison. This wasn't just fast. This was extraordinarily fast, even by the standards of objects ejected from other star systems. The chemical balance, revealed by preliminary spectroscopy, was unlike anything seen in comets native to our solar system. Early readings suggested ratios that didn't match the expected composition of icy bodies formed in conditions similar to our own planetary neighborhood. The angle of approach raised eyebrows among specialists. Atlas wasn't arriving along the plane of the galaxy like most wanderers should. It came tilted, skewed, suggesting origins not in the familiar thin disk, where most stars orbit in orderly fashion, but perhaps in the ancient thick disk, or even from regions farther out in parts of the Milky Way we barely understand. These details existed in the data. They were real, measurable, undeniable, but they were tucked away in the appendices of technical reports, buried in footnotes, mentioned only in specialized journals that few outside the astronomical community would ever read. They didn't make it into the press releases. They didn't shape the public narrative. The first impressions were comforting, yes, deliberately so. The message was clear: this is unusual, but it's safe. This is interesting, but it's understood. This is remarkable, but it's natural. And perhaps that comfort was necessary. Perhaps it was even justified. After all, the trajectory truly was safe. The mathematics truly was sound. There was no physical danger, but comfort has a way of dissolving once the deeper mysteries begin to surface. Once you start asking not just what something is, but why it's here, why now, and what it might mean. And with Atlas, those deeper mysteries were already present, waiting just beneath the surface of the reassuring announcements. The first impressions were meant to calm, but for those paying close attention, for those who looked beyond the headlines and into the actual data, the comfort felt fragile, temporary, like a thin layer of ice over deep water. And with Atlas, the deeper mystery was already beginning to show through the cracks. Reassurance is built on numbers, and at first the numbers seemed to offer exactly that solid ground, predictable outcomes, mathematical certainty. But as more data came in, one number in particular refused to be comfortably explained: the speed. And speed, unlike chemistry or shape, leaves very little room for interpretation. Speed has always been the quiet tell in astronomy. The way an object moves reveals not only where it's going, but where it has been. What forces have touched it? What history lies encoded in its trajectory? With Atlas, that number spoke louder than any photograph, louder than any preliminary spectrum. 61 kilometers per second, more than 130,000 miles per hour, a velocity that dwarfed its predecessors, nearly doubling the pace of Oumuamua and leaving Borisov trailing behind like it was standing still. At first, this fact was packaged neatly as another curiosity. Yes, it was fast. Yes, faster than expected. But interstellar space is vast and violent, and objects flung from their birth systems carry scars in the form of momentum. These things happen. The galaxy is not a gentle place. Still, the deeper the models ran, the more uneasy the data became. This wasn't just wandering, this was racing, and not in a way that current models fully explained. Planetary ejections can accelerate debris to high speeds. Gravitational slingshots around giant worlds in young star systems can add velocity. Close encounters with multiple bodies over millions of years can compound the effect. These are known mechanisms, understood processes. They happen all the time in the chaotic environments where solar systems form. But there are limits. Energy budgets in astrophysics are not infinite. You cannot extract endless velocity from gravitational interactions. There's only so much speed that can be imparted through natural chaos, and Atlas was pushing against those limits in ways that felt uncomfortable to model. Some theorized it had passed close to multiple stars in its long history, stacking accelerations across eons like compound interest, each close encounter adding a little more velocity, accumulating over billions of years until it achieved this remarkable speed. Others wondered if the velocity pointed to an origin not in the familiar thin disk of the galaxy, where most stars orbit in relatively ordered fashion, but in the ancient thick disk. That population of older stars with more eccentric, more tilted orbits. A realm where stellar dynamics are harsher, more chaotic, where objects might be flung with greater violence. Or perhaps even beyond that, perhaps from regions of the Milky Way, where conditions were so different, so extreme, that our models based on local observations simply didn't apply. These were plausible explanations, elegant in their way. They didn't violate any laws of physics. They didn't require exotic mechanisms or unprecedented events, just the ordinary violence of the galaxy playing out over timescales too long for human minds to comfortably grasp. And yet, in the quiet corners of discussion, there were other questions, the kind not raised in official press briefings, the kind whispered between colleagues after the cameras stopped rolling. Was the speed random, or was it telling us something? Could acceleration of this kind ever be mistaken for something else, something deliberate? When Oumuamua passed through in 2017, Harvard astronomer Avi Loeb famously suggested it might be a light sail pushed by starlight across the gulfs between stars, a technological artifact rather than a natural wanderer. That idea had been dismissed by most of the scientific community, filed away as provocative speculation, interesting to consider, perhaps, but not supported by the evidence. Too extraordinary a claim based on too little data. But here was another interstellar object, moving even faster, and once again the models strained at the edges of plausibility. NASA's official line remained firm as it had to be. Natural explanations were sufficient. Multiple gravitational encounters over billions of years could absolutely account for such velocity. The laws of physics held even at 61 kilometers per second. There was no need to invoke anything beyond known astrophysical processes. But in the subtext, in the uneasy glances exchanged when cameras weren't recording, lay an awareness that speed, unlike shape or chemistry, leaves little room for interpretation. It's a number, stark, unambiguous. Either it fits within the expected range of natural processes, or it doesn't. And while Atlas technically did fit, the explanations worked, the math closed, it sat uncomfortably close to the edge, close enough that the explanations felt less like solid ground and more like a tightrope stretched across a gap we didn't want to look down into. Something had driven this ancient wanderer to a pace that few had anticipated. Something in its history, something in its origin, something in the chaotic violence of whatever system once called it home. And it was already here, cutting through our solar system with the precision of a cosmic blade. The problem with speed is not just what it reveals about the past, it's what it means for the future. At such velocity, Atlas cannot be captured by our sun. There is no scenario, no gravitational trick, no subtle perturbation that could slow it enough to bind it to our system. It will not linger, it will not orbit. It will pass through, reveal itself only briefly, and vanish forever into the darkness it came from. The window of observation is finite, measured in months, not years, and within that fleeting encounter, humanity must gather what data it can ask, what questions it dares, and make what conclusions it's able to defend. Because once Atlas rounds the sun and begins its outbound journey, once it fades beyond the reach of even our most powerful telescopes, the opportunity will be gone. Whatever secrets it carries, whatever truths it might reveal about the galaxy's hidden population of wanderers, will slip away with it. And in that brief passage, that cosmic blink of an eye, humanity must decide, is what we're seeing just another comet, just another fragment of ice and rock following the mindless choreography of celestial mechanics? Or is it a messenger carrying truths we are not yet ready to face? But speed was only the first anomaly. As more sophisticated instruments turned their attention toward Atlas, another mystery emerged, one written not in velocity, but in chemistry. And what they found would prove even stranger than the speed that brought it here. When the James Webb Space Telescope turned its mirrors toward Atlas, astronomers expected refinement, not revelation. Spectroscopy has a way of cutting through uncertainty, breaking light into molecular signatures that tell stories of composition, temperature, and history. It's a tool of precision of clarification. You point it at something unknown, and it returns facts, numbers, certainties. But the story that came back was not the one anyone anticipated. Spectroscopy works by analyzing how light interacts with matter. When sunlight strikes a comet's frozen surface, molecules escape into space, absorbing and emitting light at specific wavelengths. Each molecule has its own fingerprint, its own unique pattern written in the spectrum. Water vapor appears at certain lines, carbon monoxide at others, methane, ammonia. Various organic compounds all leave their marks. Read the spectrum and you read the composition. The readings from Webb showed a coma dominated not by water vapor, the bread and butter of ordinary comets, the molecule that defines them, but by carbon dioxide. Not just elevated levels, not just a curious abundance, an 8-to-1 ratio, 8 parts carbon dioxide for every single part water, a proportion so extreme it rewrote every assumption about what a cometary body should be. On Earth, carbon dioxide is familiar. We exhale it with every breath. We monitor it in our atmosphere. We regulate it, fear it, build entire political frameworks around managing it. It's part of our daily existence, woven into the chemistry of our world. In comets, carbon dioxide has always played a role, but always a secondary one, always subordinate to water. Water is the dominant volatile in nearly every comet ever studied. It sublimates easily under sunlight, creating the glowing halos and bright tails that make comets visible across vast distances. Water is what comets are made of, fundamentally. Ice with other things mixed in. Carbon dioxide, by contrast, is usually the supporting actor. Present, yes. Detectable, certainly, but appearing in smaller quantities, a minor component of the overall chemistry. You expect to see it in spectra. You'd be surprised if it wasn't there. But you don't expect it to dominate. You don't expect it to overwhelm everything else. Until now, the data from Webb was met first with disbelief. Scientists stared at their screens, checking and rechecking the numbers. Surely there was an error. Surely the instruments had miscalibrated. Surely something in the data processing had gone wrong, producing these impossible ratios. Then came silence. The kind of silence that settles over a room when everyone realizes simultaneously that the instruments are fine, the calibration is correct, and the data is real. The uncomfortable silence of having to accept something that shouldn't exist. Then came the careful, methodical rechecking that betrays quiet unease. Could the instruments be wrong? Could some systematic error have crept into the observations? Could atmospheric interference, despite Webb's position far beyond Earth's atmosphere, have contaminated the readings? Repeated measurements dismissed those hopes. Observations from different instruments, using different techniques, analyzing different wavelengths, all returned the same impossible result. The ratio held. Atlas was exhaling carbon dioxide in volumes that made no sense. Not for something that had been drifting through interstellar space for billions of years. Not for a comet formed in any environment we understood. Theories rushed in to fill the gap, as they always do when nature presents something that violates expectations. Perhaps the comet had formed near its parent star's carbon dioxide snowline. that distance from a sun where temperatures favor the condensation of carbon dioxide over water ice. Different stars have different luminosities, different temperatures, and therefore different snow lines. Maybe Atlas formed in a system where conditions were just right or just wrong to produce this bizarre chemistry. Or perhaps cosmic rays had processed its surface across geological ages. Billions of years of exposure to high energy radiation can alter surface chemistry in profound ways. Maybe that bombardment had created a crust, a hardened shell that sealed water ice beneath, while allowing carbon dioxide to percolate upward and escape more easily. Another possibility involved an insulating dust mantle, a thick coating of fine particles that could protect water ice from sublimation while letting the more volatile carbon dioxide seep through and vent into space. This might explain both the unusual ratio and the early activity. Each explanation was plausible, elegant even in its own way. They didn't require exotic physics or unprecedented mechanisms, just unusual conditions, rare but not impossible, combinations of circumstances that might occur somewhere in the vast diversity of planetary systems scattered across the galaxy. But none of them felt entirely satisfying. None of them erased the fundamental strangeness of what Webb was showing. Because the oddity wasn't just the chemistry itself, it was the timing. At more than 3 astronomical units from the Sun, roughly 3 times the distance from Earth to our star, most comets remain quiet and inert. They're too far out for solar heating to have much effect. They should be dormant, frozen, waiting for closer approach before beginning to sublimate their volatiles in any significant quantity. Atlas was already active, already venting gas, already building a substantial coma, despite being far enough from the sun that it should, by all conventional understanding, still be asleep. It was as though it couldn't wait, as if some deeper mechanism was stirring it awake long before the usual cues, as if the rules that governed ordinary comets simply didn't apply. Publicly, NASA described the chemistry as unusual but informative, a valuable clue to planetary formation in other star systems, they said. A rare chance to glimpse alien conditions preserved in ice, an opportunity to expand our understanding of how different stellar environments might produce different chemical signatures. The language was careful, measured, framed to emphasize the scientific opportunity rather than the inexplicable weirdness. This was data to be studied, patterns to be understood, not mysteries to be feared. But privately, in conversations that didn't make it into press releases, some scientists wondered if the oddity carried implications that stretched beyond simple origin stories. Why this much carbon dioxide? Why such an extreme imbalance? Why active so early, so far from the sun's warming influence? Why now, the human mind ever hungry for meaning drifted toward more unsettling interpretations? What if the chemistry wasn't just a relic of ancient formation conditions? What if it was something designed? What if the ratios weren't random fluctuations of natural processes, but deliberate signatures, patterns, rather than substances, messages encoded in molecular abundances? The thought was quickly dismissed in official circles, too speculative, too far beyond what the evidence could support. Science deals in what can be measured, tested, falsified, and there was nothing in the spectra that demanded such exotic explanations. Unusual chemistry, yes. Unprecedented, certainly, but still chemistry. Still molecules behaving as molecules do. And yet the thought lingered, like static at the edge of reception, like a signal just below the threshold of clarity. Not strong enough to act on, not clear enough to ignore. In the end, the chemical puzzle left more questions than answers. Atlas was no longer just fast, no longer just strange in its trajectory. It was chemically alien in a way no comet had ever been. Its composition spoke of conditions of origins of processes that our models struggled to accommodate. And as it continued inward toward the sun, as more data accumulated with each passing day, astronomers knew with growing certainty that the puzzle was only beginning to unfold. Each new spectrum revealed more oddities. Each new observation added another layer to the mystery. Perhaps it was exactly what it appeared to be, a natural wanderer from another star shaped by conditions so different from our own solar systems that it emerged with chemistry we'd never encountered before. An outlier, a statistical improbability that nevertheless existed because the galaxy is vast and diverse enough to produce anything given sufficient time. Or perhaps deep within that strange shell of carbon dioxide ice, within that nucleus still hidden beneath its glowing veil of gas, Atlas was keeping secrets that chemistry alone could never reveal. Chemistry tells us what something is made of, but there's another way to listen to the cosmos, another spectrum beyond light. And when radio telescopes turned their attention toward Atlas, what they heard, or rather, what they didn't hear, would add yet another layer to the growing mystery. Silence in the cosmos is never just silence. This is one of the first truths you learn when you begin listening to the universe beyond the visible spectrum. Every star hums with electromagnetic noise. Every planet radiates. Every comet whispers through static bursts as solar wind interacts with outgassing volatiles. Space, contrary to popular imagination, is not quiet at all. It is saturated with the constant chatter of physics in action. Natural radio emissions fill the spectrum, charged particles accelerating through magnetic fields, plasma interactions, the thermal glow of matter at different temperatures, lightning in planetary atmospheres, auroral processes. The universe is never truly silent. It is always speaking, always broadcasting, always filling the electromagnetic spectrum with the noise of existence itself. That is why, when radio telescopes turned toward Atlas, astronomers expected to hear something, perhaps not much, perhaps nothing spectacular, but something. The sublimation of gases should produce detectable signals. The interaction of charged particles with the solar wind should create electromagnetic signatures. The natural hiss of a comet alive under starlight should be there, faint but measurable. There should be the familiar background chorus that accompanies any active body in space. Instead, what they heard was nothing remarkable. No narrowband signals cutting through the noise with artificial precision. No modulated transmissions that might suggest structured communication. No patterns in the static that could hint at intelligence organizing information into deliberate sequences. Just the bland murmur of a comet doing exactly what comets do. Random, chaotic, natural. Officially, this was confirmation of normality. No alien beacon broadcasting from within the icy nucleus. No interstellar transmission hidden in electromagnetic camouflage. No technological anomaly lurking in the static. The silence, or rather the ordinary noise, became another reassurance folded neatly into NASA's narrative. Atlas was natural, they said, and the radio silence proved it. Just another comet, just another wanderer, following the mindless choreography of physics. For most, this was comfort. The absence of signal meant the absence of intent. It meant Atlas was exactly what it appeared to be: ice and rock and frozen volatiles. Not a machine, not a probe, not a messenger. The universe remained comprehensible. The cosmos stayed ordinary, and humanity could continue its daily rhythms, while this alien-born fragment blazed invisibly across the depths of space before vanishing forever. But for those who dwell in speculation, for those who have spent years contemplating what contact might actually look like, silence is not the absence of signal. It can be the signal itself. The dark forest hypothesis has haunted the search for extraterrestrial intelligence for years, ever since the Chinese science fiction author Liu Cixin gave literary form to an idea that had lurked in the darker corners of SETI thinking for decades. The concept is brutally simple and profoundly unsettling. The universe might be filled with intelligent civilizations, but they remain silent, not because they don't exist, but because silence is survival. In this view, the galaxy is like a dark forest at night. Every civilization is a hunter moving carefully through the trees. To make noise, to broadcast your presence, to announce yourself to the cosmos is to invite attention. And attention in a universe where intentions are unknowable and capabilities might be godlike is the most dangerous thing of all. Better to stay quiet, better to listen than to speak, better to remain hidden in the dark forest than to light a fire that might draw predators you cannot comprehend. In such a cosmos, silence becomes strategy. The absence of communication is not emptiness. It is caution. It is wisdom. It is the collective decision of species that survived long enough to understand the risks of being known. If Atlas were a machine, if it were a probe sent across the stars to observe developing civilizations without revealing itself, what better disguise could it wear than silence? A comet that behaves like a comet, emitting nothing more than the random electromagnetic hiss of gas and dust would slip past every watchful ear. It would trigger no alarms. It would provoke no special attention beyond routine scientific observation. It would be catalogued, measured, and ultimately dismissed as natural. The perfect camouflage is not invisibility, it is unremarkability, and silence, as it turns out, is remarkably easy to maintain if you're designed for it. The chilling logic unfolds naturally once you accept the premise. If an advanced civilization wanted to send observational probes across the galaxy to monitor younger species without announcing their presence, they would not build spacecraft that broadcast their nature. They would build spacecraft that mimic the random noise of nature so perfectly that even the most sensitive instruments designed to detect artificial signals would find nothing but the expected chaos of natural processes. The question then becomes not about what Atlas is emitting, but about intent. If the silence is chosen, if a probe is deliberately suppressing any electromagnetic signature that might betray its artificial nature, then that choice suggests awareness, awareness of us, awareness of our capability to detect such signals, awareness of the risks inherent in being discovered. But if the silence is simply imposed by design, a byproduct of engineering so subtle it hides even from our paranoia, then perhaps the signal we seek doesn't lie in what we hear. It lies in what we don't hear, in the perfect absence of anything that might give it away. The scientists did their due diligence. This is what science demands. Extraordinary claims require extraordinary evidence, and before anyone could even whisper the possibility that Atlas might be more than natural, the listening had to be thorough, systematic, and comprehensive. Dozens of radio arrays across the world turned their attention to this faint visitor, the successors to Arecibo, though that great dish itself had fallen. The vast dishes of NASA's Deep Space Network, designed to communicate with spacecraft at the edge of the solar system. The Allen Telescope Array, the Very Large Array in New Mexico, even amateur SETI projects run by enthusiasts hungry for any hint of discovery pointed their smaller instruments toward Atlas and listened. The verdict was unanimous. Atlas was quiet, quiet in the way space debris is quiet, quiet in the way ancient ice drifting between stars is quiet. The radio signature matched exactly what you would expect from a natural comet at that distance, with that composition under those conditions. Broad spectrum noise, random fluctuations, no structure, no patterns, no hint of anything beyond the mindless hiss of physics doing what physics does, and still a discomfort lingered. Because silence in this case was louder than noise, it was definitive, absolute, as if the object had passed an audition for being unremarkable, and had done so flawlessly. Too flawlessly, some whispered, though they whispered it carefully and never in official channels. The problem with perfect normality is that it can feel suspicious precisely because it's so perfect. When you expect something to be slightly off, slightly unusual, and instead find it matching theoretical predictions exactly down to the last decimal point, you begin to wonder if perhaps the match is not coincidence, but design, if perhaps what you're seeing is not nature being predictable, but something else being very, very good at pretending to be nature. This is the paranoia that creeps in when you think too long about the dark forest. Every absence of signal becomes potentially meaningful. Every ordinary observation becomes potentially suspect. The universe stops being random and starts feeling choreographed. And once that feeling takes hold, it's almost impossible to shake. But paranoia is not evidence. Suspicion is not proof. And science, whatever its practitioners might privately wonder, deals in data, not speculation. The data said natural comet. The silence said exactly what we expected. And for most, that was enough. Atlas remained a scientific curiosity, not an existential mystery. An opportunity for study, not a source of dread. Yet for those who looked closely, for those who understood what perfect camouflage might require, the question remained unanswered, and perhaps unanswerable. If something wanted to hide, what better mask could it wear than the silence we had already convinced ourselves to expect? What better disguise than the ordinary electromagnetic hiss of a comet that was doing exactly what comets do, broadcasting nothing more than the random noise of sublimating ice and wind-blown dust? In the end, the silence told us nothing, or perhaps it told us everything, and we simply lacked the wisdom to hear it. Radio waves reveal what an object is saying or not saying, but there's another kind of signature written into every traveler from beyond, not in chemistry or sound, but in motion, in the path it takes, in the angle of approach, in the orbital geometry that speaks of origins too ancient and too strange for comfort. Trajectories tell stories long before chemistry or imagery can. The path of an interstellar object is not random. It is the fossil record of gravity itself, shaped by encounters stretching back across billions of years. Every curve in its orbit, every angle of approach, every subtle deviation from the expected carries information about where it has been and what forces have touched it along the way. When astronomers traced the orbit of Atlas backward through time, when they ran the calculations that would reveal not just where it was going, but where it had come from, they noticed something unsettling in its geometry, something that set it apart from the general flow of the galaxy. Unlike most visitors to our solar system, which tend to arrive moving roughly along the plane of the Milky Way's thin disk, following the broad rotation of stars around the galactic center. Like cars on a cosmic highway, this one came from an odd angle. It cut across the sky, not as a fellow traveler in the galactic current, but as a stranger, tilted, skewed, moving in a direction that suggested it belonged to an older, more chaotic population. The thin disk of the Milky Way is where most stars live. It's the flat spiral of younger stars' planets and debris that gives our galaxy its characteristic shape when viewed from outside. Objects in the thin disk tend to move in orderly fashion, orbiting the galactic center in roughly the same plane, their motions governed by the collective gravity of all the mass distributed in that flat structure. But the Milky Way has another component, an older one, the thick disk. This is the realm of ancient stars, born when the galaxy itself was younger and more violent, when collisions between proto-galaxies stirred stellar orbits into chaotic patterns. The thick disk stars don't move in a neat formation. Their orbits are eccentric, tilted at various angles to the galactic plane. They belong to an earlier epoch of galactic history, before settling and organization smoothed things into the orderly thin disk we see dominating the structure today. If Atlas emerged from that population, then it is not just interstellar, it is intertemporal, a survivor from an era when the Milky Way was raw and violent, when collisions between massive structures sent stars and debris scattering in all directions, when icy fragments like this one were flung into the gulfs between stars to wander for eons. The implications of such antiquity are profound and uncomfortable. If the thick disk connection is real, if Atlas truly originates from that ancient stellar population, then it could carry within it chemical records of a galaxy we no longer inhabit, signatures of conditions, of elemental abundances, of processes that happened before our sun was born, before the solar system condensed from its own cloud of gas and dust, before Earth existed, before life began. It would be more than a visitor from another star. It would be a visitor from another time, a message in a bottle, not just crossing space, but crossing eons, carrying testimony about what the universe was like when it was younger, stranger, more chaotic than the relatively calm galaxy we see around us today. But such antiquity forces uncomfortable questions. Could this really be debris that has survived billions of years, longer than complex life has existed on Earth? longer than continents have existed in their current forms. How does something so relatively fragile, a small body of ice and rock, perhaps only a few hundred meters across, endure cosmic ray bombardment for geological timescales? How does it survive interstellar dust collisions that accumulated over billions of years should erode it down to nothing? How does it withstand gravitational disruptions from close passes by stars, from transits through dense molecular clouds, from all the violence that space inflicts on anything that dares to exist in it for too long? The orbital inclination whispers, "This is not recent. This is not ordinary." When simulations were run to trace Atlas's path backward through galactic time, when astronomers tried to identify where it might have originated, the results only deepened the mystery. Most interstellar objects, when traced back, point toward plausible ejection scenarios around familiar types of star systems, young stellar nurseries where planetary formation is still chaotic, binary star systems where gravitational interactions can fling debris to escape velocity, regions we understand mechanisms, we've modeled origins that fit comfortably within our framework of how these things happen. Atlas did not fit. Its approach angled its velocity, its trajectory through galactic space, suggested a history that couldn't be easily traced to any single simple origin. It bore the marks of something that had been traveling so long through so many regions of the galaxy, encountering so many gravitational influences along the way, that its original birthplace had been obscured by the accumulated chaos of its journey. Perhaps it had even begun outside the regions of the galaxy we typically study. Perhaps its origin lay in the outer halo, or in structures even more ancient and poorly understood. The data couldn't say for certain. The uncertainties were too large, the timescales too vast, the number of possible encounters too numerous to reconstruct with confidence. Two interpretations emerged, neither entirely satisfying. For some astronomers, the orbital evidence confirmed what spectroscopy had already suggested. Atlas was an ancient messenger, older than our solar system by perhaps billions of years. It carried within it chemical and physical testimony about the Milky Way's formative epoch, about the galaxy as it existed when stars were just beginning to organize into the structures we see today. It was a scientific treasure, a sample of deep time delivered to our doorstep by the random mechanics of galactic motion. For others, the angle was too strange, too deliberate seeming. If an object wanted to arrive undetected, wouldn't it avoid the main thoroughfares where most traffic flows? Wouldn't it slip in from directions where fewer eyes are pointed, where the unexpected approach might be mistaken for randomness rather than recognized as intentional? The thought was dismissed almost as quickly as it formed. Orbital mechanics doesn't lie. Gravity doesn't deceive. The math that describes Atlas's path is the same math that describes every other object in space. There is no room in celestial mechanics for intention unless that intention manifests as thrust, as course corrections, as deviations from natural motion. And no such deviations had been observed. NASA emphasized the natural explanations: orbital eccentricity produced by ancient gravitational scattering, random chance distributing objects across all possible approach angles, given enough time and enough wanderers. The eccentric orbit was unusual, yes, but unusual is not impossible. It is simply rare, and rare things happen when you survey enough of the sky for long enough. Yet the eccentric trajectory lingered in the imagination like a riddle, not threatening, not explainable, but undeniably odd, a curve written against the canvas of stars, hinting that the true story of Atlas is older and stranger than any we have yet dared to tell. An orbit that speaks not just of where it came from, but of how long it has been traveling, of how many stellar encounters shaped its path, of how many epochs of galactic history it has survived, and perhaps in the paranoid corners where speculation runs wild of how deliberately it might have chosen this path, this angle, this moment to arrive. The orbit told us Atlas was ancient. The chemistry told us it was strange. The silence told us nothing or everything. And now, as it continued inward toward the sun, another date loomed on every astronomer's calendar, a moment when all mysteries might be revealed or deepened beyond resolution. October 29th, perihelion, the moment of truth. Every comet has its moment of truth, the instant when it draws nearest the sun and either flares with brilliance or crumbles into silence. For Atlas, that moment was marked on calendars almost as soon as its orbit was calculated. October 29th, 2025. The date loomed like an astronomical deadline, a countdown not just to a physical turning point, but to an unveiling. Perihelion. The word itself carries weight in astronomical circles. It marks the moment of closest approach to the sun, when solar radiation reaches its peak intensity, when frozen volatiles sublimate most violently, when the true nature of a comet reveals itself under the relentless scrutiny of starlight. It is the great revealer, the moment when ambiguity gets stripped away by heat and light. For Atlas, this close brush with the sun would test whatever secrets lay frozen within its ancient nucleus. Heat relentless and impartial would pour into ice that hadn't been warmed this way for billions of years, perhaps not since it first condensed around its parent star in some distant stellar nursery. What would happen when that ancient cold finally met the full fury of our sun's radiation? Telescopes worldwide had been booked months in advance. Observing time on major instruments is precious allocated through competitive proposals and careful scheduling. But for perihelion, exceptions were made. Resources were shifted. Priorities were adjusted. This was not an opportunity that would come again. Ground-based observatories prepared to track the brightening coma as solar radiation sublimated ice into gas. They would monitor changes in brightness, in the distribution of dust, in the development of tails. Every shift in appearance would be documented, analyzed, compared against models of cometary behavior. The Hubble Space Telescope, aging but still sharp-eyed, would capture images for as long as Earth's atmosphere and orbital geometry allowed. Its position above the distorting effects of air would provide views unavailable to ground observers, resolving details that might otherwise blur into noise. And the James Webb Space Telescope, humanity's most sophisticated eye on the cosmos, would watch with its spectrographs carefully tuned, ready to catch whatever molecules boiled off as temperatures surged, ready to see if the bizarre carbon dioxide dominance would persist or if heating would unlock deeper layers of composition hidden beneath that strange outer shell. The excitement that built as the date approached was not born of fear or expectation of catastrophe. No one anticipated danger. The distance at perihelion, approximately 1.5 astronomical units from the Sun well beyond Earth's orbit, guaranteed safety. This was not about threat, it was about revelation. Perihelion is where comets show their true nature. Some brighten dramatically, becoming visible to the naked eye as they spray tails of gas and dust across millions of kilometers of space, painting temporary brush strokes across the solar system canvas. Others fracture under the stress, their nuclei splitting apart as thermal expansion and outgassing create forces the structural integrity cannot withstand, leaving behind only a fading smear of debris where a solid body once existed. For an ordinary comet, both outcomes are plausible and well documented. Hundreds of perihelion passages have been observed over the centuries. The physics is understood. The behavior, while variable, falls within predictable ranges. But for Atlas, the stakes felt higher. The chemistry was already strange. The trajectory already unsettling. What would happen when the Sun poured its full energy into an object that might not have experienced such heating in longer than Earth has existed, when ancient ice preserved in the deep freeze of interstellar space for eons suddenly encountered the intensity of close solar proximity? Speculation ran wild in the weeks leading up to October 29th. Some astronomers theorized that heating might unlock water ice hidden beneath the carbon dioxide crust. If that strange outer layer was indeed just a shell created by billions of years of cosmic ray processing, or by the specific conditions of its formation, then perihelion might crack that shell open. The molecular balance could shift dramatically, revealing deeper layers of Atlas's story, previously concealed beneath the unusual surface chemistry. Others wondered if the carbon dioxide dominance would only intensify. Perhaps the heat would drive even more sublimation of that volatile flooding nearby space, with carbon in proportions never before observed. Perhaps the unusual chemistry was not surface deep, but went all the way through, making Atlas fundamentally different from anything in our solar system's comet inventory. The most speculative whispered about activation, about dormant systems buried within the ice, waiting for the cue of solar heating to awaken. If Atlas were more than a comet, if it carried within it something designed rather than naturally formed, perihelion would be the stage where it might drop its disguise. When energy flooded into systems that had been sleeping for geological ages, when the moment came to reveal purpose, this speculation remained confined to private conversations and internet forums. No serious scientist would voice such thoughts in official channels. The evidence didn't support it. The data pointed toward natural explanations, and professional credibility demands restraint when discussing extraordinary possibilities. But the thoughts were there nonetheless, quiet, persistent, growing as the countdown ticked down. NASA's language remained carefully calm, as it had throughout the entire Atlas encounter. Official statements emphasized that perihelion brought no danger to Earth. The object's distance, nearly 1.5 astronomical units at closest approach, kept it safely out of range of any planetary disruption. There would be no gravitational perturbations affecting Earth's orbit, No debris shower, even in the unlikely event of fragmentation, no scenario under which this event posed any risk to our world. Yet even the official releases admitted to curiosity. The chemistry was unusual, the behavior potentially unpredictable, and the data that perihelion might yield was potentially groundbreaking. Whatever happened on October 29th would be documented with unprecedented precision by the most sophisticated instruments humanity had ever pointed at a comet. If Atlas had secrets, this was when they might emerge. As the days ticked down, the feeling shifted. It felt less like waiting for a routine astronomical event and more like anticipating an arrival. Each night, sky seemed to hold its breath. Astronomers sharpened their instruments and triple-checked their observation plans. Journalists prepared headlines for various scenarios. Science communicators crafted explanations for the public. And even casual sky watchers, those with backyard telescopes and a passing interest in cosmic events, began asking the question that everyone was thinking: what happens when it heats up? Because when ancient ice meets modern sunlight, when material that has been frozen since before our world was born finally experiences the warmth of a star, again something always changes. The question was not whether Atlas would reveal itself. The question was what exactly it would choose to reveal. The countdown had begun, and unlike most astronomical events, where prediction is certain and outcomes are known before observation confirms them, this one carried genuine uncertainty. No one knew for sure what would happen when October 29th arrived. The models offered possibilities, not certainties. The data suggested ranges, not answers. All anyone could do was watch and wait and wonder if the moment of truth would bring revelation or only deepen the mystery that Atlas had been since the night it was first detected. The countdown was already happening, and everyone was watching. But even before perihelion arrived, as telescopes continued their patient vigil, images began accumulating. Portraits of Atlas captured from Earth, orbit, processed, and analyzed, distributed to the world. And in those images, familiar and strange in equal measure, lay another layer of the puzzle. When the Hubble Space Telescope turned its aging but still keen instruments toward Atlas, the images that returned looked deceptively ordinary. A faint star, slightly smeared, surrounded by a fuzzy glow. The coma spreading outward like breath condensing on cold glass, and a thin suggestion of a tail barely visible, curling away from the direction of the sun in the eternal dance between solar pressure and cometary debris. For decades, this is what comets have looked like through Hubble's patient eye. Classic, familiar, textbook, the same visual signatures that define these icy wanderers wherever they're found. The soft glow of sublimating volatiles, the asymmetric distribution of dust, the gentle fade from bright center to dark background. Nothing in these portraits would alarm a casual observer, but within those familiar forms, astronomers knew lay details that whispered rather than shouted, details that could either reassure or unsettle, depending on how you chose to read them. The portraits revealed what appeared to be a textbook comet, and yet not quite. The coma had bloomed more strongly than expected for an object at Atlas's distance from the sun, at over 3 astronomical units out. most comets would still be relatively quiet, their activity muted by the weakness of solar heating at such range. Yet Atlas's coma was already substantial, already bright, already releasing volatiles in quantities that suggested chemistry not driven by water ice, the usual culprit for early activity, but by something more volatile, something more alien. Each pixel of light captured in Hubble's detectors carried information about size and brightness, about how dust scattered sunlight, about how gas escaped from the nucleus and expanded into the vacuum of space. Together, these pixels formed the most public face Atlas had yet presented to Earth, a face both familiar and strange, comforting in its resemblance to other comets, unsettling in its subtle deviations from the norm. The images invited two interpretations, depending on what you wanted to believe. For those who wanted to see nothing more than another comet, the portraits offered comfort. Here was visual confirmation that Atlas behaved as comets do. It glowed. It shed material. It responded to sunlight in predictable ways. Whatever chemical oddities the spectroscopy revealed, whatever mysteries surrounded its origin and velocity, the photographs showed something fundamentally recognizable. Ice and dust doing what ice and dust always do when warmed by a star. But for those who suspected something deeper, something other, these same portraits became masks, beautiful, convincing masks that concealed rather than revealed. This is what made Hubble's images so haunting. They were not high-resolution blueprints that laid the nucleus bare. At best, Hubble resolved a blur where the solid core hid within the cloud of its own escaping atmosphere. The true shape remained concealed, the true structure hidden, the actual surface features obscured by the very material sublimating from them. The nucleus itself, that small solid body at the heart of all this gas and dust, remained invisible, veiled, protected from scrutiny by its own exhalations, and this raised an uncomfortable logic. An object designed to masquerade as natural could hardly choose a better disguise. What better way to hide than behind the visual signature everyone expects to see? To look at a comet is to see nothing but what it chooses to shed. The nucleus keeps its secrets. The core remains unknown, even as Hubble's portraits circled the globe, released to the public with careful captions and technical footnotes. The deeper question simmered beneath the surface of those beautiful images. The irony was not lost on those who thought about it carefully. Perfect camouflage is not invisibility, it is conformity. It is looking so exactly like what you're supposed to be that no one thinks to question it. And Hubble's classic comet photographs might be precisely the reason we stop asking dangerous questions. Here was the most advanced telescope of its generation, an instrument that had revolutionized our understanding of the cosmos, giving us images that felt almost comfortingly antique. A ball of fuzzy light, a halo of gas, a tail streaming in sunlight. The same pictures we'd been seeing of comets for decades. The same visual signatures that children draw when asked to sketch a comet. Hubble's output matched those simple drawings almost perfectly. In that familiarity lay both reassurance and danger. We trust what looks normal. We dismiss what matches our expectations. We stop examining closely when the surface appearance confirms what we already believe. And if something extraordinary wanted to hide, what better strategy than to look precisely as ordinary as possible? The portraits showed us a comet, But they couldn't show us what lay beneath the coma. They couldn't reveal what structure, if any, hid within the nucleus. They couldn't distinguish between a solid body of ancient ice and something else wearing a shell of ice as protective coloring. This was the psychological test hidden in Hubble's beautiful images. They asked a question without words. Are you satisfied with the mask, or do you dare imagine what might hide behind it? The comet's face, captured in Hubble's careful eye, smiled back at us from the void, serene, familiar, unthreatening. It looked exactly like what a comet should look like. And that perfection, that flawless conformity to expectation, was itself the most unsettling detail of all. Because when something looks too perfect, when it matches prediction too exactly, when it behaves precisely as theory suggests, it should you begin to wonder, is this nature being predictable, or is this something else being extraordinarily good at pretending to be nature? The light we saw was real. The glow was genuine. The gas and dust were actual molecules, actual particles, measurable and analyzable. But light can illuminate and deceive in equal measure. And what we saw in those portraits might have been exactly what we were meant to see. Nothing more, nothing less. The perfect performance of a comet being a comet. Deep within that luminous veil, Atlas kept its secrets, and the portraits beautiful, as they were told us nothing about what those secrets might be. Images showed us what Atlas looked like. Spectra told us what it was made of. Silence told us what it wasn't saying. But between what the data reveals and what the imagination fears lies the darkest territory of all, the space where science ends and speculation begins, where questions have no answers, only possibilities, and some of those possibilities are more unsettling than any certainty could ever be. The data tells one story, clean, measurable, bounded by the limits of what instruments can detect and what mathematics can calculate. It speaks of velocities and compositions of trajectories and temperatures of photons counted and spectra analyzed. The data is clear. The data is precise. The data says comet, but imagination tells another story entirely. And in the gap between science and speculation, in that uncomfortable space where evidence thins and possibility thickens, lie the darkest hypotheses, the scenarios we whisper rather than shout, the thoughts we explore in private rather than present in press conferences, the interpretations that haunt us precisely because they cannot be disproven, cannot be dismissed with certainty, cannot be exorcised by data alone. 5 such hypotheses have emerged around Atlas, 5 ways of reading the same evidence that transform comfort into unease, 5 possibilities that, however unlikely, however unsupported by direct proof, refuse to be silenced by reassurance. Hypothesis 1. The perfect camouflage. Consider the logic of concealment. If you were a civilization advanced enough to cross interstellar distances, technologically sophisticated enough to observe other species across the galaxy, what would your reconnaissance probe look like? Would you send gleaming spacecraft that announced their artificial nature to any civilization capable of looking up? Would you broadcast your arrival with electromagnetic signatures that screamed technology to anyone listening? Or would you wrap your instruments in the most ordinary materials? The universe provides ice, dust, rock, the ubiquitous debris that fills the space between stars, that wanders through every solar system, that draws no special attention because it is everywhere and always has been. The best disguise is not one that looks like a disguise. The best disguise is one that looks like nothing special at all. Atlas fits this profile with uncomfortable precision. Every characteristic it displays is just odd enough to raise questions, but not so extreme as to demand exotic explanations. The chemistry is unusual, yes, but explicable through rare formation conditions. The velocity is high, certainly, but achievable through natural gravitational encounters. The radio silence is complete, but exactly what you'd expect from an inert body. The ancient trajectory is remarkable, but possible given enough time and luck. Each anomaly, taken individually, falls within the bounds of natural variance, and that paradoxically is what makes it suspicious to those inclined toward suspicion, because it means Atlas has not failed a single test of normality. It has passed every examination we can apply. It behaves exactly as a natural comet should behave, and perhaps that perfection is itself the tell. Nature is messy, inconsistent, full of surprises that don't fit cleanly into categories. Real comets are prone to fragmenting unexpectedly, to sputtering as they approach the sun, to displaying brightness variations that models struggle to predict. Their spectra vary wildly, some rich in water, others dominated by carbon monoxide or methane, each one a unique chemical fingerprint of its formation conditions and evolutionary history. Inconsistency is their signature. Unpredictability is what we expect. So when Atlas presents with anomalous composition, when it moves faster than anticipated, when it arrives from an unusual angle, these facts raise questions, but none of them demand that we abandon natural explanations. After all, comets are supposed to surprise us. That's what makes them interesting. The unusual is, in the context of cometary science, actually quite usual, which means that if you wanted to hide technology beneath layers of natural material, the strategy would be straightforward. Wrap your instruments in ice, coat your probe with regolith, ensure that every outward signal matches what astronomers expect from frozen debris wandering between stars. When sunlight strikes, allow it to vent gas as any comet would. When viewed through a spectrograph, ensure the molecular ratios remain odd enough to be interesting, but not so bizarre as to be impossible. From the outside, nothing seems amiss. Just another comet, just another wanderer, perhaps a bit strange in its particulars, but still fundamentally comprehensible within the framework of natural processes. Only a whisper of wrongness lingers, a feeling that cannot be quantified or measured, a sense that the perfection itself might be the problem. And perhaps that's exactly the point. Perhaps the goal is not to be invisible, but to be unremarkable, to hide not in darkness, but in ordinariness, to pass unnoticed, not by avoiding detection, but by matching expectations so perfectly that no one thinks to look deeper. If that is the strategy, then Atlas has executed it flawlessly. Hypothesis 2. What if it's not leaving? Everyone says the same thing with confidence, backed by mathematics. It will leave, it must leave. The hyperbolic trajectory guarantees escape. The math is clear, unambiguous. When eccentricity exceeds 1, when velocity surpasses escape threshold, the object cannot be captured. It will swing around the sun and continue outward, forever gradually accelerating as solar gravity pulls at it one last time. before releasing it back into interstellar space. But what if the mathematics only describes the present? What if the future holds possibilities the current trajectory doesn't yet reveal? What if the flyby is not departure at all, but the setup for deceleration? In orbital mechanics, velocity is everything. Too much speed and you escape the sun's gravity, well, forever, doomed to wander the galaxy until you encounter another star's pull, or drift endlessly through the void. Too little speed, and you fall captive, your trajectory bending into an ellipse that brings you back again and again in predictable cycles. But what if Atlas carries the means natural or otherwise to alter its velocity at precisely the right moment, to shed just enough speed during its closest approach to shift from an interstellar trajectory into something more permanent, to transform escape into capture? The sun, after all, is not just a source of light and heat. It is a gravitational well capable of slowing objects as easily as flinging them away. For spacecraft designed by human hands, gravitational slingshot maneuvers around planets are routine, carefully calculated methods of stealing momentum from one body to add to another. These techniques allow us to send probes to the outer solar system and beyond without carrying impossible amounts of fuel. What if for something far older and far more advanced than our primitive spacecraft stars themselves could serve as the ultimate engines of deceleration? What if the close brush with our sun's gravity is not an accident of trajectory, but a deliberately chosen moment to bleed off velocity, to drop from interstellar speeds into something slow enough to remain? This speculation finds no support in the data. Every measurement taken of Atlas aligns perfectly with a natural hyperbolic escape. Its path shows no deviations that might suggest thrust or braking. Its velocity profile matches what gravity alone would produce. There is no evidence of artificial maneuvering. None. And yet the perfection itself unsettles those inclined to suspicion. Objects flung from stellar nurseries billions of years ago should show scars of their chaotic origins. Their trajectories should wobble slightly, betraying the accumulated effects of countless small perturbations over geological time. They should not glide with serene predictability along paths that match theoretical curves with uncanny precision. But Atlas does exactly that. Its motion is textbook, flawless, as if the trajectory had been not just followed but rehearsed, calculated, designed. If someone wanted to engineer a path that mimicked nature perfectly, would it look any different from this? The truly scary thought, though, is not that Atlas might crash into us or linger near Earth. The distances involved are too vast for that. Our world is nowhere near its path. The geometry of its approach places it safely distant from any planetary interaction. No, the unsettling possibility is that its path has been chosen not for escape, but for insertion. That somewhere past perihelion, when all eyes have turned away, when interest has waned and observation has ceased, it might execute a maneuver so subtle that no one would notice until years later, when someone thinks to check and realizes it never left. It could drift into a stable orbit in the outer solar system, vanish into the clutter of the Kuiper Belt, where thousands of icy bodies circle in the twilight beyond Neptune, become indistinguishable from the native debris, settle into an orbit that would keep it out there indefinitely silent and patient, watching from the shadows of the solar system's edge. And silence would still reign. No transmissions would give it away. No sudden course corrections would betray intent. Nothing overt would announce that the scenario everyone predicted escape into interstellar space had failed to occur. Only the quiet act of slowing down, of remaining where mathematics insists it should not be able to remain. The greatest disguise is not hiding, it's pretending to leave while never actually going. Hypothesis 3. The silent seeds. Silent invasion looks nothing like Hollywood imagines. There are no armadas blotting out the sky, no laser beams carving through atmosphere, no dramatic landing craft descending on flames of thrust, no alarms blaring as defenses scramble to respond to obvious threat, just dust and gas shedding into the void. Indistinguishable from the natural outgassing every comet performs when heated by the sun. Ordinary, expected, beneath notice. But within that dust perhaps lie microseeds, machines smaller than bacteria, or engineered organisms designed for specific purposes, tiny enough to evade detection by any instrument currently watching, tough enough to endure the brutal environment of interstellar space, cosmic radiation, extreme cold, the occasional high-velocity dust grain impact. Clever enough to know when to activate, when to begin the slow process of waking from dormancy that might have lasted geological ages. What would trigger them? Perhaps the electromagnetic chatter of a technological civilization, radio transmissions leaking into space, television broadcasts, radar pulses, the artificial signals that announce to anyone listening that intelligence has emerged on a world and begun manipulating the electromagnetic spectrum for communication. Perhaps atmospheric chemistry detected from orbit, rising carbon dioxide levels that indicate industrial civilization, or specific combinations of gases that cannot occur naturally that signal technology at work. Or perhaps they are far more patient than that, designed to remain dormant not just for years or decades, but for centuries or millennia, waiting until their host world reaches a threshold of development that makes it worth the attention of whoever sent them, waiting until the civilization below reaches a stage where contact or observation or whatever the true purpose might be becomes meaningful. The advantage of such a strategy is its subtlety. No dramatic entrance alerts the inhabitants. No obvious threat triggers defensive responses. Instead, the seeds simply ride comets and asteroids like spores, riding wind spreading through star systems over millions of years. Most never land anywhere significant. Most worlds they drift past remain untouched, either devoid of life or not yet developed enough to warrant attention. The vast majority of seeds are wasted lost in the immensity of space. But you only need one success, one fertile planet at the right stage of development, one world where the seeds finally find conditions worth activating in. And then the waiting ends. Skeptics correctly point out the near impossibility of this scenario. The radiation environment of deep space should shred any complex molecules over billion-year timescales. The violence of cometary outgassing with material accelerating from a solid surface to escape velocity in minutes should scatter and destroy any fragile structures embedded in the ice. And even if some incredibly robust seeds somehow survived both the journey and the release, the dilution factor alone would be staggering. billions of microscopic particles dispersed into an ocean of emptiness, with only the tiniest fraction ever encountering a world, let alone landing on one and finding conditions suitable for activation. The objections are valid. The physics works against it. The probability approaches zero. And yet, in the realm of speculation, impossibility is not the point. The point is to imagine what patience, combined with sufficiently advanced technology, might look like. To consider strategies that operate on time scales so vast that individual failures become irrelevant. To recognize that if you're willing to wait millions of years for success, you can afford to waste billions of seeds. The galaxy is old enough, large enough, patient enough to make even astronomically unlikely scenarios eventually occur. The chilling beauty of the silent invasion hypothesis lies in its subtlety. It reframes threat as something that doesn't need to rush, doesn't need to announce itself, doesn't need to act within timescales humans can comprehend. The invasion, if it is, one might have already happened centuries ago, millennia ago. The seeds might already be here, dormant in soil or ocean, waiting for conditions none of us will live to see. If Atlas carried such a system, it could pass through deposit, nothing immediately detectable, and continue its journey. Decades later, or centuries, when memory of this interstellar visitor has faded into historical footnote, when its trail has gone cold and its passage exists only in archived observations, the seeds might stir, might begin their slow activation, might start whatever process they were designed to execute, and by then, Atlas would be long gone, so far away that no one would think to connect the strange phenomena appearing on Earth with the comet that passed through our solar system generations earlier. The legacy would remain hidden in places we'd never think to look, in soil samples dismissed as contamination, in atmospheric chemistry attributed to natural processes, in patterns of change too subtle to trigger alarm until they've already progressed beyond the point where understanding their origin matters. And by the time we realize, if we ever do, Atlas will have vanished into the infinite dark between stars, its purpose fulfilled, its mission complete, its silence maintained until the very end. Hypothesis 4. Ghost technology. Imagine technology that outlives its creators. Machines so advanced, so enduring, that they continue functioning long after the civilization that built them has crumbled into dust. Probes that wander the galaxy for eons, still following their programming, still executing missions, still recording data that no one will ever retrieve, because the hands that launched them, the minds that designed them, the worlds that birthed them are gone, erased by time, by war, by the unforgiving mathematics of cosmic hazards that eventually claim all intelligence. This is the possibility some whisper when they look at Atlas and wonder if its strangeness might indicate something beyond nature, not a probe sent by a living civilization to observe us, but something older, something that has outlived its purpose while remaining trapped in its programming. Ghost technology drifting through the void, performing tasks whose meaning was lost billions of years ago. The thought is almost too large to hold comfortably. Our own machines, even the most sophisticated spacecraft we've launched, are fragile things. Voyager, our farthest flung ambassador, has been traveling for less than 50 years. and already its systems are failing, power fading, instruments shutting down one by one. Within another decade or two, it will fall silent, its mission ended by the simple exhaustion of the radioisotope thermal generators that keep it alive. Give it a few million years in the interstellar environment, and there would be nothing left. Radiation damage would destroy its electronics. Micrometeorite impacts would puncture its systems. The slow degradation of materials in the vacuum of space would reduce it to unrecognizable debris. Yet what if somewhere in the galaxy, some other intelligence solved the problem we haven't? What if they built machines designed to last not decades or centuries, but eons, durable enough to endure interstellar flight across timescales that make geological ages look brief, patient enough to keep functioning when no one remains to listen to their reports? In this framing, Atlas becomes more than a comet. It becomes an emissary of ghosts, a messenger from a civilization that may have reached extraordinary heights before falling to whatever fate awaits all technological species that survive long enough to face the universe's indifference. If it were engineered, its disguise would be flawless. It would need to be to survive this long without being recognized for what it was. It sublimates like a comet because it's coated in the ice of interstellar space, accumulated over millions of years of drifting through molecular clouds. It shines like a comet because its surface reflects sunlight exactly as ice and dust should. It follows orbital mechanics like a comet because whatever propulsion or maneuvering capability it once had has long since been exhausted or shut down to preserve core functions. From the outside, examining it with telescopes and spectrographs, we would see nothing but what nature provides. The perfect camouflage is not active deception, but passive accumulation. Let time and space do the work of concealment. Let ice coat your hull. Let dust embed in your surface. Let billions of years transform you from obvious artifact into something that looks like it was never anything but natural. Its silence then becomes not a failure to communicate, but a strategy, or perhaps simply the inevitable result of power systems that have degraded beyond the ability to broadcast, of communication systems designed for receivers that no longer exist, of programming that prioritizes passive observation over active transmission. The ideal probe is one that goes unnoticed, that blends so seamlessly with the natural debris of the cosmos that it passes through system after system, recording what it sees, storing data in whatever memory substrates can survive geological time, waiting for a retrieval that might never come. And then comes the even more haunting thought: what if its makers are no longer here? What if the civilization that launched Atlas, if it is indeed artificial, fell long ago to the same cosmic hazards that threaten all intelligence war, that destroyed their worlds, resource depletion that collapsed their expansion, environmental catastrophe that rendered their home uninhabitable, or simply the mathematics of time, the statistical inevitability that all things, even civilizations, eventually end? In that case, Atlas is not a messenger awaiting reply, not a spy reporting to its masters, not even a probe executing the will of living beings. It is an orphan, a machine stripped of context, performing actions whose purpose died with those who programmed them, following instructions that may no longer make sense, that may never have anticipated a scenario where the civilization that launched it ceased to exist before the mission was complete. This scenario shifts the emotional tone entirely. It's no longer about threat or danger or invasion. It becomes about legacy, about what remains when everything else is gone, about the possibility that our own machines might one day wander the galaxy long after humanity is extinct, still following our commands, still carrying our data, still bearing witness to the fact that we once existed, even though no one remains to care. Ghost technology speaks to us not about alien intentions, but about our own mortality. It suggests that the galaxy might be filled not with living civilizations, but with their ruins. Silent machines drifting between stars, performing missions whose purposes have been forgotten, serving masters who have been dust for eons. If Atlas is nothing more than a natural rock and ice, it is extraordinary for what it reveals about galactic chemistry, about the diversity of planetary formation conditions, about the processes that create and scatter cometary bodies across the Milky Way. But if it is ghost technology, if it carries within its ancient shell the remnants of engineering from a civilization that no longer exists, then it is extraordinary for what it reveals about us, about the future that might await our species, about the fragility of technological civilization in a universe that does not care whether we survive, about the possibility that one day, long after we're gone, our machines too might wander alone through the dark orphaned ambassadors of a species that reached for the stars and fell back into silence. Hypothesis 5. We are the experiment. Perhaps the most unsettling possibility is also the simplest. What if the question is not, what is Atlas? But what does our reaction to Atlas reveal about us? Every calculation we perform, every measurement we take, every headline we write, every signal we send into the void, hoping for reply, all of it generates data, not about the object itself, but about us, about how a young technological civilization responds when confronted with something it cannot immediately explain, about whether we react with curiosity or paranoia, with scientific rigor, or superstitious fear with cooperation or fragmentation. A civilization advanced enough to send disguised probes across interstellar distances would not need Atlas to announce itself or perform obvious maneuvers. It could learn everything it needs simply from watching how we respond to its presence. Our calculations reveal our level of technological development. Our debates reveal our philosophical maturity or lack thereof. Our reassurances and our fears, our official statements and our conspiracy theories all paint a picture of a species still figuring out its place in the cosmos, still wrestling with the implications of intelligence beyond Earth. If this is true, then the silence of Atlas is not a failure to communicate. It is a choice, a deliberate decision to remain passive, to function as a perfect mirror that reflects our own reactions back at us without adding any signal of its own. It doesn't need to reveal itself, because what matters is not what it is, but how we respond to the mystery of what it might be. The object glows faintly in our telescopes, trailing its coma like countless comets before it, behaving exactly as nature would predict. But the true signal might be flowing in the opposite direction, carried not in radio waves or visible light, but in human behavior itself. in the papers we publish, in the press conferences we hold, in the fears we voice, and the reassurances we offer, in how quickly we leap to natural explanations or how readily we entertain exotic ones. In this light, the distinction between natural and artificial almost ceases to matter. The presence of Atlas, whatever its origin, has already altered us. We measure it obsessively. We speculate endlessly. We project our hopes and fears onto its icy surface. We reveal ourselves in how we talk about it, how we study it, how we explain it to each other and to the public. And if somewhere something is watching, if some intelligence embedded in that wandering nucleus is recording not just astronomical data, but anthropological observations, then our reaction alone might be all the data it needs. Whether we greet the unknown with curiosity or suspicion, with scientific discipline or wild speculation, with unity or division, these responses reveal the nature of our species more clearly than any direct communication ever could. The paradox this creates is more troubling than any chemical anomaly or orbital peculiarity. If the watchers remain silent, our own voices fill the void, echoing back our assumptions and anxieties. If they take no action, our actions stand as the only record of this encounter. The danger might not lie in what Atlas does, but in what it draws out of us, in how it makes us reveal ourselves without ever asking a direct question. Perhaps that is the deepest silence of all. The realization that even if nothing stirs within that icy shell, even if no alien machine waits behind the coma, even if Atlas is nothing more than ancient frozen debris following mindless orbital mechanics, its presence has still observed us. In its silence, it has still learned what kind of species we are, and the question that lingers, unanswerable and uncomfortable: would we like what it has seen? 5 hypotheses, 5 ways of reading the same silence, the same chemistry, the same trajectory. 5 possibilities that haunt because they cannot be proven false. But speculation, however compelling, is not knowledge. And in the face of fear and uncertainty, there is one anchor that holds steady: mathematics, physics, the unchanging laws that govern motion and matter. Between paranoia and peace lies the realm of numbers, and numbers, unlike stories, do not lie. In the space between speculation and paranoia, physics offers a steady hand. When the imagination runs wild, when whispers of probes and invasions swirl through late-night conversations, when the mind conjures scenarios of observation and exposure, the numbers remain immutable, indifferent, unswayed by human anxiety or hope. They remind us that Atlas, whatever else it might be, is not chaos. It is calculation. Its path is written in the language of gravity, and gravity does not negotiate. The velocity has been plotted on charts with margins of error measured in fractions of a percent. The trajectory has been refined through thousands of observations taken over months. Every position measurement, every brightness estimate, every spectroscopic reading feeds into models that have been tested against centuries of celestial mechanics. Against speculation, against fear, mathematics speaks with the calm authority of inevitability. This is where it came from. This is where it goes. This is how close it will pass. And this is when it will leave. Astronomers take comfort in this predictability, this reduction of cosmic mystery to differential equations and orbital elements. The Minor Planet Center issues bulletins updating Atlas's position. Each revision narrowing the uncertainty, each calculation strengthening confidence. Like pulse checks on a patient, these regular updates confirm that everything proceeds as expected. The numbers tighten, the trajectory solidifies. What was once possibility hardens into certainty. Within those numbers, there is no room for panic. Atlas will not collide with Earth. The mathematics forbids it. The closest approach has been forecast to the hour, and that approach keeps the object safely beyond any distance that could threaten our world. The perihelion passage has been calculated with precision. The outbound path arcs cleanly back toward the darkness, never to return. These are not predictions subject to revision. They are certainties derived from laws as fundamental as the universe itself. Whatever else Atlas might be natural wanderer or something stranger, it remains bound by the same equations that govern planets, moons, and every comet that has ever crossed our sky. The universe may be strange. Its contents may surprise us. But that strangeness still obeys law. Gravity still pulls. Momentum still conserves. Energy still distributes itself according to rules that do not bend for mystery or fear. There is a quiet beauty in celestial mechanics. Where imagination conjures intent and purpose, physics reveals only inevitability. The smooth hyperbola traced by Atlas through space is not the improvised path of a visitor choosing its route. It is the choreography of mass and motion, the predictable consequence of velocity meeting gravity. Radiation pressure from sunlight nudges the trajectory slightly. Outgassing adds subtle perturbations as volatiles escape the nucleus. But every force has been catalogued, every influence anticipated and incorporated into the models. For the public orbital diagrams offer a peculiar form of reassurance. To see the comet's future sketched out decades in advance, to watch animations showing its path through the inner solar system and back out into the void, is to confront uncertainty with certainty. There are no hidden maneuvers waiting to surprise us. No sudden turns that will redirect it toward Earth. No secrets lurking in trajectories yet to unfold. Only the serene arc of mathematics, carrying the object outward, beyond the reach of our telescopes, beyond the influence of our sun back into the anonymity of interstellar space. Even the velocity that initially unsettled scientists faster than models predicted higher than seemed easily explicable becomes less threatening when framed in the steady language of physics. Energy exchange, stellar ejections, gravitational billiards played out over eons in the chaotic environments of young star systems. The speed is high, yes, but not impossibly so. Not beyond what natural processes can produce given enough time and enough violence. Physics does not eliminate mystery, but it contains it, keeps it from spilling over into panic, transforms the inexplicable into the merely unusual, reminds us that even the strangest observations must still fit within the framework of natural law. Yet the comfort that physics provides is double-edged. The precision that reassures us also reminds us how small we are compared to the machinery it describes. We can plot the path of this comet with exquisite accuracy, predicting its position years into the future. But we cannot alter that path, cannot slow it or capture it or redirect it. We can calculate its speed down to meters per second, but we cannot change that speed by even a fraction. We know, but we cannot act. The numbers are not negotiable. They describe what is and what will be, without regard for what we might wish. They leave us as spectators, comforted by understanding but powerless to intervene. We watch inevitability glide past precisely as mathematics predicted it would, precisely as it must. Perhaps that is the deepest reassurance of all. In a universe filled with uncertainty, some things remain anchors, equations that have held true for billions of years, laws that do not change, regardless of how far from home we look or how strange the objects we observe. In the steadiness of physics, in the reliability of mathematics, we find calm. Between fear and speculation, between paranoia and wonder, the numbers offer something that no story can provide: silence, certainty, and peace. Physics tells us what will happen. Mathematics assures us of safety. But neither can answer the deeper question that Atlas has forced us to confront. Not about trajectories or velocities, but about meaning, about what this visitor and the others that came before it might reveal about our place in the cosmos. And that question leads us to the true worst-case scenario. Not collision, not invasion, but something far more unsettling. The phrase worst-case scenario usually summons visions of fire and collision, of skies torn apart by impact, of civilization ending in dust and flame. When people hear that an object from beyond our solar system is approaching, the primitive brain immediately imagines catastrophe. The asteroid that killed the dinosaurs, the Tunguska blast, Hollywood disaster films, where humanity scrambles desperately to deflect cosmic doom at the last possible moment. With Atlas, that nightmare was dismissed almost as soon as it appeared. The orbit is clean, the distance safe, the mathematics certain. It will not strike us. There is no physical threat, no danger of collision, no scenario under which this ancient wanderer poses any risk to Earth or its inhabitants. But the absence of physical danger does not close the question. Instead, it sharpens it. Perhaps the worst case was never about rocks and trajectories at all. Perhaps it was about what we would have to confront within ourselves once the object appeared, about the knowledge we could no longer avoid, about the questions we could no longer postpone. Because the danger of Atlas lies not in what it might do to us, but in what it makes undeniable. We are no longer dealing with abstractions. For generations, the possibility of interstellar wanderers was theory, a line in computer models, a probability whispered in scientific journals, speculation about what might exist out there in the vast spaces between stars. Interesting to consider, but distant, academic, not real in any immediate sense. Now it is real, and these visitors are arriving with unsettling frequency. The pattern alone is enough to stir deep unease. Oumuamua first startled us in 2017 with its strange shape and inexplicable acceleration. Borisov reassured us in 2019 by behaving exactly as a comet should. And now, Atlas has unsettled us again with speed and chemistry that push against the boundaries of comfortable explanation. One detection could be dismissed as cosmic accident. Two suggested something worth paying attention to. Three makes it undeniable that the galaxy is filled with these travelers, that they pass through our solar system regularly, that we are embedded in a vast river of debris flowing between the stars. And if the galaxy is filled with such wanderers, then the question of their nature can no longer be pushed aside. Are they all natural, all the mindless debris of planetary formation scattered across the void? Or could some, even just one, be something more? That question leads directly to the two possibilities we fear most, two scenarios equally terrifying in their implications, two outcomes we cannot distinguish between with the data we have, and between them lies the true worst case. The first possibility, we are not alone. One of these wanderers, perhaps Atlas itself, might carry within it intention, not a comet, but a device, not a relic, but a message, not debris, but design. The thought thrills and terrifies in equal measure. If we are being observed, then we are vulnerable, stripped of the privacy we never knew we had. Our world cataloged by intelligences we cannot comprehend, our development monitored by eyes. We cannot see our future, perhaps already determined by judgments we had no part in making. If we are contacted, if some response comes, some signal emerges, some undeniable proof arrives that we are not the cosmos's only voice, we might not survive the encounter unchanged. The history of contact between civilizations at different technological levels is not encouraging. The less advanced are usually absorbed, disrupted, destroyed, not through malice necessarily, but through the simple reality of asymmetry. The silence that Atlas offers provides no reassurance, because silence can be strategy. If the object is more than dust and gas, if it carries instruments that have been watching us since the moment it entered detection range, then it already knows far more about us than we know about it, about our technology, our divisions, our strengths, and our weaknesses, our hopes and our fears. The worst case here is not invasion in the Hollywood sense. It is exposure, the realization that we are being studied, patiently, invisibly, without our consent or even our awareness until too late. That the autonomy we thought we had, the belief that humanity's story is ours alone to write, has been an illusion all along. We are no longer the authors of our own narrative. We are subjects in someone else's study. The second possibility is darker still. We are utterly alone. Atlas is nothing but debris, natural as any comet, and every interstellar visitor we will ever detect will tell the same story. The galaxy is littered with fragments of broken worlds, with ice and rock ejected from countless planetary systems. But nowhere in all that vastness across all those eons is there another voice, another intelligence, another species that looked up at the stars and reached for them. Either civilizations never arise. Intelligence is so improbable, so contingent on such an unlikely series of accidents that we are the only ones. Or civilizations do arise, but they never last. They reach a certain level of development and then collapse, self-destruct, or simply fade away before they can leave any lasting mark on the cosmos. In this scenario, Atlas becomes not a messenger, but a reminder, a piece of evidence in the case that we are alone, that the silence we hear when we listen to the stars is not strategic concealment, but simple absence. The galaxy is full of matter, but empty of meaning, full of chemistry, but devoid of consciousness, except for the fragile spark that briefly flickered on Earth. And if absence is the truth, if the great filter that silenced other potential civilizations is real, then it may yet await us. We may be living in the brief window between emergence and extinction, looking up at a universe full of debris from species that also thought they were special, that also believed they would be the exception, that also failed to survive whatever test the cosmos imposes on intelligence. The comet drifts past. The sky does not fall. Life continues beneath stars that remain indifferent to human anxiety. But in the wake of Atlas, the weight of realization lingers. Perhaps the danger is not in the impact that will never come. Perhaps the danger is knowledge itself. The knowledge that we might be watched, studied, cataloged by intelligences we cannot fathom. Or worse, the knowledge that we are not worth watching, that we are alone in a cosmos that will never acknowledge us, because there is no one left to acknowledge. Both possibilities are equally terrifying, and we cannot know which is true. The worst case is not death. It is not knowing, not the certainty of threat or the comfort of safety, but the impossibility of ever determining which reality we inhabit. Not an answer, but an eternal question. Not resolution, but permanent ambiguity. And within that uncertainty, we must somehow find a way to live. This, then, is the real worst-case scenario. Not the collision that will never happen, not the invasion that has not come, but the confrontation with two possibilities we cannot escape. Either we are observed vulnerable, no longer masters of our own story, or we are alone witnesses to the great filter that has already consumed others and may yet be waiting for us. Both pierce the heart of our existential security. Both force us to question assumptions we have carried since we first looked up and wondered if anyone was looking back. Both have been possible since the moment Atlas appeared in our detectors. And the worst part, we may never know which one is true. Two possibilities, both terrifying, both unresolvable. And caught between them, we find ourselves revealed not by what Atlas is, but by how we respond to not knowing. Fear, it turns out, is a form of data, and we are generating it constantly. Fear is a measurement as real as the light curves plotted by astronomers or the spectral lines etched across Webb's instruments. When Atlas streaked into our awareness, it did more than challenge models of chemistry or orbital mechanics. It probed us, tested us, revealed us in ways no telescope ever could. The object became a mirror, and in its reflection we saw not an alien messenger or cosmic threat, but ourselves, exposed in how we respond to the unknown, revealed in our first instinct when confronted with something we cannot immediately explain. From the very first announcement, fear ran parallel to curiosity. NASA's calm assurances, no danger, no threat, were repeated in headlines around the world, sensible, measured, backed by mathematics. And yet beneath those carefully chosen words lay an undercurrent of unease that no amount of data could quite dispel. Why, people asked, must the experts emphasize safety so strongly if there is truly nothing to fear? The repetition itself became suspicious. The more NASA said, "Don't worry," the more some worried. Because reassurance, when delivered too forcefully, too frequently, begins to sound like the very thing it denies concern. The anxiety is written into our evolutionary wiring. The primitive brain still flinches at approaches from the dark, even when the rational mind understands the mathematics of safe passage. Even when told explicitly that something will pass at distances measured in hundreds of millions of kilometers, something deeper still calculates. Threat still scans for danger, still refuses to fully relax. In online forums and social media threads, speculation blossomed like spores in damp earth. Was Atlas really a comet? Or was it a probe? A weapon? A disguised ark carrying something we couldn't yet imagine, drifting through the void between stars? The silence of the comet did not quiet these questions. It amplified them, because in every rumor, every fearful projection, every conspiracy theory spun from fragments of data and oceans of imagination, we find data points not about Atlas, but about humanity itself. The stories we tell reveal what we fear: tales of invasion, of hidden watchers, of silent judgment from cosmic observers. These narratives say less about what the object actually is, and far more about what we dread becoming, or what we secretly hope to find. Each fear is a confession of something deeper than rational analysis. Fear ultimately is anticipation. It speaks of futures we imagine most vividly, of outcomes we cannot stop picturing, even when logic says they're unlikely. The notion of a decelerating probe, disguised in ice and dust, speaks to our suspicion that intelligence must be watching us, even if we cannot see the watchers. The idea of microseeds hidden within the nucleus reveals our unease with biology, with contagion, with loss of control over our own world. And the dark forest hypothesis, whispered in speculative corners of the internet, reflects an awareness of our own predatory instincts projected outward onto the galaxy. We know what we might do if we found a younger, more vulnerable civilization, and we fear that others might do the same to us. Each fear is a confession. Each anxiety encodes data about our psychological landscape, about what keeps us awake at night when we contemplate our place in the cosmos. While scientists tracked Atlas's trajectory with exquisite precision, culture tracked it with metaphors. Every headline, every viral post, every hushed conversation over dinner tables, all of it became part of a larger data set, revealing not what Atlas is, but who we are, how deeply we yearn for connection with something beyond ourselves, and how profoundly we mistrust that connection when confronted with the possibility it might actually exist. Fear reveals a paradox at the heart of the human condition. We want the universe to notice us, to acknowledge that we exist, that we matter, that we are not alone in the vast indifference of space. But we also desperately want to remain unnoticed, to maintain the privacy we never knew we valued until faced with the possibility of losing it. In this sense, the worst-case scenario may already be happening, not in the comet itself, but within us. Not because Atlas is a probe or a threat, but because its arrival has exposed the fragile balance between wonder and dread that defines our relationship with the unknown. If we fear too much, we close the door to discovery. We retreat into paranoia, seeing threats in every anomaly, refusing to engage with anything that challenges our comfortable assumptions. But if we fear too little, we might stumble unprepared into whatever truths the universe eventually reveals, lacking the caution that survival sometimes demands. Atlas may be nothing more than ice rock and carbon dioxide, ancient debris following mindless trajectories determined billions of years ago. But the shadow it casts is psychological stretching across our entire species. In its passage, it has delivered a kind of message, after all, not encoded in chemistry or transmitted via radio, but reflected in our own responses. Fear itself has become the data, and we are the experiment being observed, if not by Atlas, then by ourselves, watching how we react when the cosmos delivers something we cannot fully explain. But fear is not the only data we generate. There is another pattern worth noting, another detail that unsettles when examined too closely. Not about what Atlas is, but about when it arrived. Because timing in a universe billions of years old may be the strangest coincidence of all. It is one thing for an object to wander into our solar system. The galaxy is vast, and gravitational chaos ensures that debris gets scattered everywhere given enough time. Sooner or later, something from elsewhere will pass through our neighborhood. This is expected, inevitable even, but it is quite another thing for it to arrive now, precisely now, when humanity is uniquely positioned to notice. For billions of years, Atlas may have been coursing through the darkness between stars, unseen, anonymous, indistinguishable from the trillions of other wanderers drifting through the galaxy, following paths written by ancient gravitational encounters, carrying within them the chemical signatures of stellar nurseries that may no longer exist. Yet its arrival coincides with almost uncomfortable precision with an age when our telescopes never sleep, when automated systems sweep the heavens with tireless dedication, when our species possesses both the curiosity to look and the technology to capture what we see, when we are for the first time in our history capable of recognizing an interstellar visitor for what it is. The timing feels too perfect, too theatrical, as if scripted by something with a sense of dramatic timing. Skeptics insist this is nothing more than probability playing out on a grand scale. Interstellar objects must number in the countless billions. Their random trajectories ensure that some will eventually pass through any given star system. Given enough time and the growing sophistication of our instruments, discovery was inevitable. We built better telescopes, expanded our sky surveys, and finally started catching what had always been there but previously invisible. This explanation is rational, supported by statistics, comfortable in its mundanity, and yet inevitability does not erase the uncanny resonance of the moment. Out of the infinite expanse of cosmic possibility, Atlas arrives at the precise juncture when human eyes are finally open wide enough to see it, when we have just barely achieved the technological capability to detect such faint, fast-moving objects against the background stars. The coincidence tempts darker thoughts. What if the timing is not coincidence at all? What if Atlas, whether natural or something stranger, represents something more deliberate than chance? A test, perhaps, delivered only when a species has reached the technological adolescence necessary to notice it. After all, what better way to be recognized by a developing civilization than to arrive in its line of sight precisely when it has acquired the tools to detect you too early, and you pass unseen, your presence meaningless. Too late, and the civilization might be advanced enough to recognize you as artificial, to analyze you in ways that pierce your disguise, but arrive at just the right moment when they can see you, but cannot yet fully understand what they're seeing, and you become the perfect test, a mystery calibrated to their exact level of development. Some scientists recoil from such speculation, preferring the safety of statistics and the comfort of random chance, and they may well be right. History reminds us that humans rarely encounter the unexpected without attaching meaning to it, without seeing patterns where only randomness exists. When Halley's Comet returned in 1910, panic gripped parts of the world, driven more by superstition than science. People feared that Earth would pass through the comet's tail and be poisoned by cyanogen gas. The fear was irrational, unsupported by the physics, but it spread nonetheless because humans cannot help but see significance in celestial events. We are wiser now in 2025, more sophisticated in our understanding, and yet still haunted by the suspicion that timing might mean something, that if the cosmos wanted to whisper to us, wouldn't it choose precisely this moment, this era, where we can see but not yet touch, where we can analyze but not yet control, where we are aware enough to wonder but not advanced enough to know for certain? The darker side of timing is that it plays directly into our deepest fears about significance. If Atlas had arrived a century earlier, it would have slipped by completely unnoticed, its passage leaving no mark on human consciousness. A century later, perhaps we would catalog it with calm efficiency, one among many such wanderers documented by mature astronomical infrastructure. But arriving now as one of the very first interstellar visitors we have ever confirmed, it takes on disproportionate weight. We cannot help but ask why it appears at this fragile intersection of human history, when our species teeters between the mastery of space and the risk of collapse, when we are just beginning to understand our place in the galaxy, but still so uncertain about our future in it. The truth may simply be randomness, probability distributing events across time without regard for meaning or narrative. What feels like perfect timing may be nothing more than the anthropic principle. In action, we notice this particular arrival because we happen to be watching when it happened to pass through, and yet the effect is indistinguishable from design, a cosmic messenger materializing exactly when we are capable of seeing it, exactly when we are ready to wonder whether its timing is accident or answer. Perhaps in the very act of wondering, the timing has already achieved its purpose, whether that purpose was intended or simply emerges from our need to find meaning in coincidence. No matter whether Atlas was sent or stumbled into our view, it arrived when we could notice, when we had questions to ask, when we were capable of wonder, and perhaps in the grand scheme of things, that is the only timing that ever mattered. Timing raises questions. Fear reveals truths about ourselves. And now, as Atlas completes its swing around the sun and begins the long journey back into darkness, we are left with the aftermath, not of collision or invasion, but of knowledge, of questions that will outlast the object that inspired them. The countdown has reversed. Atlas has swept around the sun. Perihelion has passed. The brightness that peaked during closest approach is already fading. Now the comet is outbound, accelerating toward the edge of the solar system and the darkness beyond. We can still track it for a while. Weeks, certainly. Perhaps months if we're fortunate. And the weather cooperates and telescope time remains available. But eventually, inevitably, it will fade beyond the reach of even our most powerful instruments. It will become a speck among countless specks, then a memory cataloged in databases, then simply another entry in the long list of objects that passed through and vanished. What it leaves behind is not conclusive answers or definitive proof, just data, mountains of it, spectra and trajectories, images and measurements, orbital elements refined to extraordinary precision, chemical compositions analyzed in unprecedented detail, all of it carefully archived, available for anyone who wants to look to question, to reinterpret years or decades from now, when new instruments or new theories might reveal meanings we cannot currently see, and questions, so many questions without solutions. This is the nature of interstellar visitors. They arrive briefly, reveal glimpses, then vanish forever, leaving us with fragments, pieces of a puzzle we can never quite complete because the picture itself remains unknown. But in its brief passage, Atlas accomplished something no comet before it had managed. It forced a confrontation, not with physical danger, but with existential uncertainty. It asked questions we cannot ignore, cannot dismiss, cannot answer with the data available. Are we alone? And if not, are they watching? The worst case scenario may already have happened, not dramatically, not obviously, but quietly, invisibly, in a way we might never be able to confirm, in the way we cannot quite shake the feeling that something has changed, that something has shifted in our understanding of the universe and our place within it. Perhaps the worst case is not about what Atlas is, but about what it has made us realize, that we are vulnerable, that our knowledge is limited, that the cosmos is far stranger than we are comfortable admitting, that the silence we hear when we listen to the stars might be strategy rather than emptiness. Two possibilities still stand unresolved and unresolvable. If we are being observed, then Atlas has already stripped away the illusion of privacy we never knew we valued. We have been placed in a position of exposure subjects in an experiment we did not design and cannot escape. If we are alone, then Atlas has confirmed the great filter is real, that others have risen and fallen before us, that civilizations reach for the stars and fail, and that we might be next. Both possibilities are terrifying. Both change everything about how we see ourselves and our future. And yet life continues. The sun rises, planets orbit, commerce and conflict, and the daily concerns of billions proceed exactly as they did before. Because that is what humans do. We adapt. We absorb even the most unsettling revelations and fold them into the background of ordinary existence. What seems earth-shattering today becomes accepted truth tomorrow, and the day after that, simply part of how things are. Atlas has taught us, if nothing else, that the universe does not owe us explanations. It does not need to reveal its secrets on our timeline or in terms we find comfortable. It can send messengers without clear messages. It can present mysteries without solutions, and we must learn to live with that ambiguity, that uncertainty, that permanent state of not quite knowing. When Atlas finally fades from view, disappearing into the darkness from which it came, it will not carry the mysteries away with it. Those remain with us, embedded in our collective psyche, written into our fears and hopes, recorded in every spectrum. We captured every debate. We sparked every sleepless night spent, wondering what it means that we are no longer alone in noticing visitors from beyond. And perhaps that is the truth we must accept. The worst case already happened, not when Atlas appeared, but when we realized that the universe contains questions we may never be able to answer. That certainty is a luxury we no longer possess, that we must find a way to live with doubt. We look up at the night sky now differently than we did before, knowing that between those stars things drift, ancient things, strange things, things that might be watching us or might not care that we exist at all. and we cannot know which possibility is worse. Atlas is gone now, fading into memory, into data, into history, but it has changed us, not through collision or invasion, not through any direct action at all, but simply by arriving, by being noticed, by refusing to fit comfortably into categories we thought we understood. The comet brought no answers, only questions that will outlast any memory of the object itself, questions we will carry forward into whatever future awaits our species, questions that define us now more surely than any certainty ever could. And in the darkness, where Atlas has disappeared, the silence remains, waiting, watching, or perhaps simply being indifferent to our need for meaning, our hunger for connection, our desperate hope that we are not alone in wondering what it all means.